So yesterday we were talking about transformations, and we started out talking about the different vocabulary words that we have with transformations. So remember, pre-image is the figure before you transform the figure. Image is the figure after you have done the transformation. And remember, they label it in different ways. And then the rule is going to tell you specifically what happens to the X and Y values. Okay. After that, we were talking about three different transformations, and these had a kind of a similarity that we kind of mentioned at the end of the day. So remember, rotations are where you're turning the figure around a point. Reflection is where you're flipping it over a line. And then a translation is where you take the figure each point and you kind of slide it. You're going to either, and remember I said you can't really move it at a diagonal directly. They have to tell you how far you're going to move it left or right. And then they'll tell you how far to move it up or down. Okay. And so, like, for instance, if I move this one, I guess to the right a little bit and then up, notice it still does that slide. Okay. So what we were talking about before we kind of left each other was what's kind of different about these types of transformations compared to a dilation. And so just to kind of refresh our memory on a dilation is a transformation that either makes the figure bigger or smaller. Okay, it does what's called dilated. Okay, and so that's what a dilation means. All right, so one thing that I wanted you to kind of figure out, and you guys did figure this out, is whenever we are looking at the pre-image and we're comparing it to the image, when we do one of these types of transformations, it is actually a little bit different than when we're comparing the image and the pre-image for a dilation. And the thing that you guys realized is when you do a rotation, a reflection, or a translation, the pre-image is congruent, meaning it's the same shape and the same size as the image. So the pre-image and the image are the same shape and size when you do one of these. However, when you do a dilation, the pre-image and the image are not the same size. So that means that they're not congruent, but you would call them similar. Okay, and now similar, just like if you look down here, congruent has a symbol. It has a symbol of a little equals mark and a little squiggly over it. Similar actually has a symbol too. Similar is just the little squiggly, or it's called a tilde, but I kind of call it a squiggly because it looks like a squiggle. Okay, but that's what you should know about the pre-image and the image when you dilate something, is they're similar because they still have the same shape, which means that the angles are the same because that's what gives it the same shape, but the size is different. And so that does mean that we have to kind of describe them in a different way. And so kind of summing this up, where we didn't get to, I guess in the notes, was right here. The thing I wanted you to kind of realize is if one shape can become another, so like if you can take a pre-image and you can get an image out of it using a transformation, the two shapes might be congruent or just similar. So if you're rotating it, reflecting it, or translating it, then the two shapes, the pre-image and the image, will be congruent, meaning that the shape and the size will be exactly the same between the pre-image and the image. But if you dilate it, meaning that you make it bigger or smaller, then you need to remember that the two shapes are not going to be congruent, but they're going to be similar. Okay? And so there is a term that will come up in this class that you will see mentioned quite a bit, and I want you to know what it means. And that term is called a rigid motion. Okay? And so all of this right here kind of talks about what a rigid motion is. All right? So it says rotations, reflections, and translations are called rigid motions. And so anytime you're seeing, like in a worksheet, or if maybe you're doing an activity, if it's talking about a rigid motion, or they might say use a rigid motion to transform this figure, what they're telling you to do is to either rotate or reflect or translate that figure, okay? Because these are what are called rigid motions, okay? So that's what they're meaning when they say to use rigid motions to do this, okay? So these are called rigid motions because these are the ones where the pre-image, the figure before you transform it, the pre-image, and the image are congruent. That's what it takes to be what's called a rigid motion, is the pre-image and the image have to be congruent. Okay, and then we can write the symbol for congruent. It's that little, you got the equals with a little squiggly on top of it. Oh, my parentheses got messed up. So let's fix that. So there we go. All right, so this is the definition of a rigid motion. I wanted you to be able to see that so that you have what the definition is. So the definition of a rigid motion, it is a movement of a figure where the image, the figure after the transformation, is congruent to the pre-image. This means that because these are the three transformations where the pre-image and the image are congruent, this means that rotations, reflections, and I'm going to abbreviate so it'll fit in here, and translations are all rigid motions, okay? And then I wanted you to kind of point out this, which one would not be the rigid motion or a rigid motion, and that would be dilations, because with dilations the size of the shape is changing, and so that means that like with dilations the image and the pre-image would not be congruent, and we talked about they would be similar instead, which is different, okay? So something I do want to kind of, I guess, make you aware of is what is actually happening when you dilate. So I'm going to do it like a little example with you just so you can be aware of what's going on when you dilate something, all right? So let's say that we had a rectangle. So there's a rectangle, and remember, to be a rectangle, all of the angles have a measure of 90 degrees, okay? So I'm going to put a little 90 degree in there. And let's say that the length of this side is 3 inches, and then the length of this side is 4 inches. Okay? They might tell you to dilate this figure, and they might say, the formal language that they would use is dilate it with a scale factor of 2. What they're saying when they tell you to dilate it with a scale factor of 2 is you are going to double the size of that figure. So if you're doubling it, that means you're going to take each length of that figure and multiply it by 2. Okay? So when you do that, it's going to be twice the size of when it was, or what it was. So if I take 3 and I double it, this side of this, after I've dilated it, would have a length of 6 inches. And then this one, if I dilate that with a scale factor of 2, meaning that you multiply it, double it by 2, that means you take 4 and you multiply it by 2. So 4 times 2 is 8 inches. And so we just dilated that figure, okay? So what I want you to realize is with dilations, you're going to be multiplying the lengths of things by some number, okay? And so that's actually going to be different than all of the other things that we do in terms of transformation. So like rotations, reflections, and translations, you're not going to necessarily be multiplying by a number to transform it, okay? So kind of putting this all together, because we are multiplying, I want you to realize that anytime you multiply, so we're going to write this down, anytime you multiply the lengths of the figure, or if it's on like a coordinate plane or a graph, you might be doing that to coordinates. You do the same thing, you just multiply the numbers in the coordinate by that scale factor, okay? But anytime you're multiplying the lengths or the coordinates by a number, the pre-image and the image are actually no longer going to be congruent because it's going to change the size of it, right? And so that's what I want you to kind of put together with this is anytime you're multiplying by a number, the pre-image and the image are no longer congruent. They're going to be similar as long as you're multiplying by the same number, of course. So I'm going to put the symbol for congruent since we've wrote that a couple times. All right, so that's something I want you to realize with dilations, okay? So this is kind of just an introduction to transformation. So now we're going to concentrate on one specific type of transformation. And the transformation that we're going to focus on today is translations, okay? So you're going to flip your paper over, and we're going to start talking about translations, all right? So let me adjust this real quick. All right, so remember, a translation, when you are translating something, you are sliding it. And then I talked about you're going to slide it left and right, so many, and then you're going to slide it up or down, okay? There's two different things that could tell you to translate it. One of them is what's called a vector. And then the other one that they could use to tell you how to translate it or where to slide it, in other words, would be the rule, okay? And so we're going to look at what both of these tell you and how to read them because they will look different. And then we're going to do some examples, all right? So the vector, like I said, it's going to tell you, so it tells where to slide the figure. Where to slide the figure. All right, the vector is going to look like this. It's got like little sideways, I call them carrot things, so like little sideways carrots. And then it's going to have one number and then a comma and then another number. What these numbers tell you, like I said, is it's going to tell you where to slide it. So if you remember, I said it's going to have to tell you how far left or right to slide it, and then how far up or down. So that's what each of these numbers do. So this first part, I call it kind of like the X part of it, because if you think of it like a coordinate, it's kind of like where your X value would be, and that's going to help you to remember that it goes left and right. So this is like your X part of it. So what that number tells you is how far to slide that figure, left or right. And you'll just take each coordinate and move it one at a time, okay? And then this other number, I call it like the Y part, because it's kind of where the Y would be in a coordinate. That is going to tell you how far up or down to move it. And that the reason for that is because the y-axis goes up and down, okay? So if you were looking at a vector, okay, I told you it's going to have the little sideways carrots, and then let's say that the vector has a -4 and then a 2. Well, remember that first number is going to tell me how far left or right to slide it. So how do we know which way that is? Well, think about, this is the reason why I call this the x-axis. So think about the x-axis. X-axis goes sideways, right? So if that's my x-axis, then the y-axis would look like that. So we'll talk about that in a second. But if we're going -4, well, think about the direction. So if I go that way on the x-axis, it's going to my positive numbers. And then if I go this way, to the left, then it's going towards negative. So if that number is negative, that actually means that we have to move left that many. So you're going to take wherever that coordinate is, and this would tell you have to move it left, and it's a 4, so we'd move it left 4 units. Okay? So then this number, well, if you look, that number is going to tell us how far up or down. So that's like my y part. So think about your y-axis. If I go up, that's where my positive numbers are. If I go down, that's where my negative numbers are. So if it's a +2, that would be up. So that, because it's positive, so that tells me I have to move that figure up 2. Okay, so that's how you read a vector to know how to move your figure. All right, so now a rule is going to be similar, but remember I talked about a rule is actually going to be very specific towards what is exactly happening to your x's and y's. So it will look different. So a rule tells what happens to specifically the x and y values. And so when we are when we are translating a figure, the only thing that's going to happen to your x and y values is you're either going to be adding or subtracting a number to the x and y values. Those are the things that are going to translate it. Okay, so when you look at the rule, like I said yesterday, it's going to have like an X, Y, and an arrow to begin with, okay? And the reason for this is it's saying, okay, you're going to take your X and Y values and then you're going to do this with it, okay? So with these, you're going to have X, and it's either going to be adding X to something or subtracting. So I'll put like plus or minus, and then you're going to have some number. And then for the other part, it's going to have a y, and it's going to be adding or subtracting some number to y. Okay, so just to kind of give you an example, you might have something like this. And I'm going to, let's write it right here. So let's say that you had this rule right here. You had x plus 2, and then y minus 6, okay? And you were trying to figure out what's going on. Well, there's two ways to talk about this, because it's actually telling you two things. You can read it just kind of how you did the vector thing. To do that way, you're just going to look at this number and that number, and it'll actually do the same thing as what happened here. Or you can read it in terms of what's actually happening to the x's and y's, okay? So if you read it kind of like a vector, then remember that first number tells me how far left or right to move it. And then that second number, so the number that's with the y, will tell me how far up or down to move it. Okay, so if I kind of put that together, that means that I have to move it, I'm going to write it right here, up 2. And then this one, well, it's a -6, so that means I have to go down, because that's the one that tells me up or down. So I have to go down 6, okay? Now, if you're looking at it in terms of the rule in and of itself, this is actually telling you, like literally telling you, you have to take each of the x values and add 2. And that's actually the thing that moves it up 2. And then you have to take each of the y values that you see and subtract 6. And that's actually what moves it down 6. Okay, so let's do a couple examples so that you can see how this plays into examples. And then hopefully you'll be good with the worksheet. All right, so this first one says translate triangle ABC using this rule. And then it gives you the coordinates. It says graph the pre-image and then list the coordinates of the A prime, B prime, C prime. So that would be the image. Okay, so if we're looking at this rule, so we got x, y, arrow, x minus 2, y plus 1. So it's written kind of like this is, all right? We're going to read what that tells us. So you can read it in terms of kind of like we did the vector. What does that -2 and that 1 tell me? Or you can actually look at and apply it to the coordinates in and of themselves, which I'll show you in a minute, all right? So what does this tell me I have to do? Well, that first number tells me how far left or right to move it. So it's a -2, so that means I have to move it left 2. And then the second number tells me how far up or down, so that means I have to move it up 1. So I'm going to graph the original figure, and then I'm going to do this to each of those points. So we've got an A at -2, 4, right there. We've got a B at 3, 1. We've got C at 2, -3. So there's my original figure. And then we're going to connect them. So if you have a ruler, you can use a ruler. If you don't have a ruler, you can use like the edge of a sheet of paper to kind of make nice straight lines. I just happen to have a ruler, so we're going to make our figure. So this is the original figure, and then I'm going to translate it, in other words, slide it with how it tells me to slide it. All right, so I have to take each of those points and I have to move it left 2 and up 1. So I take this one, left 2 and up 1. So A ends up right there. B, left 2 and up 1. So B would end up right there. And then C, left 2 and up 1, right there. So what I just did is I translated, and notice how I'm labeling them with the primes, I just translated that figure. So if they were just asking you to graph it, then you would be done. But this one also asks us to write the actual coordinates of the image, so I'm going to do that in a second. And then also notice, typically I will dot the image just so that I can see in my graph which one, so that I know that they're different. So I know which one's the image and which one's the pre-image, okay? So all I have to do now is just tell the coordinates of those points. So if I look at A prime, well, it started the origin to tell the coordinate. So we go 1, 2, 3, 4. I have to go back 4, so that's -4. And then from there I have to go up 1, 2, 3, 4, 5. So up 5 would be a +5. So A prime ends up at -4, 5. And then I do the same thing for the rest of them. So I'm going to figure out where B prime is. It's at 1, 2. And then C prime is at 0, -2. 0, -2. So there we go. So that is where my image landed. All right. So the next one, it says you've got triangle XYZ, and it has this as its original coordinates, and I know that because it doesn't have a prime with it. It says after a translation, so in other words, after they slid this figure, the coordinate of Y prime, so they're just telling you about Y prime, is at 2, 3. And then they actually want you to tell the coordinates of that whole figure. So one way that you could do this is you could graph the original one and then graph this point right here, which is where Y landed, and then see what happened to Y, and then do the same thing to the other coordinates, and you'll have that. Or you could actually use this rule and what we talked about with what's happening to the X and Y values, and you could do it without even having to graph it. So I'm going to show you how to do that. So how do you do it without even having to graph it? Well, because they're giving me Y and where it landed, I'm going to just focus on Y right now. So Y originally was at -3, 1, and it landed at, so Y prime, Y prime was at 2, 3. Okay, so it was originally at -3, 1, and it landed at 2, 3. All right, what I'm going to do is I'm going to figure out what happened to my X's and what happened to my Y's. And so if you need to graph this to see it, you are more than welcome to graph it, because graphing it will help you visually. Okay, and I'll show you in a second. But what I'm going to also show you is how you can just look at it to figure out what happened. So I talked about with translations, you're just adding or subtracting numbers to the X and Y's. So what I'm going to look at is I'm going to look at my X values, and I'm going to ask myself, what number do I add or subtract to -3 that gives me 2? Because those are my X values. So to go from -3 to 2, I'm going to have to add a number. And so if you think about it long enough, you'll realize that if I take -3 and I add 5, I get 2. So that means for this translation, I am actually supposed to take my X values and add 5. That was what was happening to my X values. So now I do the same thing with the Y values. So I'm going to look at this one. So what do I do to 1? That gave me a 3. What number do I add or subtract? And if you think about it, you'll realize that if I take 1 and I add 2 to it, I get 3. So that means we're taking the Y values and we're adding 2. Okay? Now, if you didn't realize that, again, you could graph this and then just see how far left or right do you slide it. So you'll realize that you have to slide it to the right 5. And then how far up or down do you go to get from this point, or excuse me, from this point to this point? And you would realize you have to actually go up 2, and you could get the same rule. So once you have the rule, then all you have to do is apply it to your other coordinates. So we're going to do the same thing that we did here to these coordinates, okay? So if I take x, which was originally at 5, 4, and I take the x value and add 5, then where would x prime land? Okay, so if I take the x value is 5, if I add 5 to it, I get 10. And then with 4, that's the y value. So here it's telling me I have to take the y values and add 2. So if I take 4 and I add 2, I get 6. So that's actually where x prime would land. And then I'm going to do the same thing with z. So I'm going to copy z down here. Okay, so I have to take the x values and add 5, and I have to take the y values and add 2. So if I take this x value and add 5, 2 plus 5 is 7. And then if I take the y value, this tells me I have to add 2, so negative 4 plus 2 gives me negative 2. So there are my coordinates. So I know that x prime is at 10, 6, z prime is at 7, negative 2, and then I already knew that y prime was at 2, 3. So there is my answer. Okay. So number 3, it says triangle A prime, B prime, C prime is a translation of the triangle ABC. So they have translated a triangle or slid it for you, and they want you to write the rule. So it's kind of like what we did here, but now they're making you look at the graph. So the rule, remember, always starts out with an XY arrow, but then you have to look at what's happening to the X's and then what's happening to the Y's. So there's 2 ways to do this. Since we've already kind of figured out how to look at the coordinate to figure that out, I'm going to show you how to figure this out from the graph. So to figure out the rule from a graph, you're going to pick a coordinate in your graph. It doesn't really matter which one. You just pick one from the original figure. So like, for instance, if I picked A, what I'm looking at is what do I do to go, like in terms of left and right, to get from A to A prime, and then what do I do to go up or down to get there. So like if you notice, I have to go left so many, and then I have to go down so many. Okay, that actually is going to tell you your rule. So the left and right part, remember, is the x part. So we're going to put an x, and then we have to go back, which means we go left. So that means we're subtracting something from x, and then we just count. So make sure you count the spaces and not the lines, because sometimes that messes you up. So that's 1, 2, 3, 4, 5, 6, 7. We have to go 7 to the left. So that means we're taking our x values and subtracting 7. Okay, so that's the x part of my rule. Now the up and down part. So I had to go down. So that means we're taking our y values, and because we're going down, we're subtracting a number, and we just count how far we go down. So we're right here, and we're going to count 1, 2, 3, 4, 5, 6. So we're going down 6. Okay, so there's my rule for that problem. So all of these coordinates are going to fit that same rule, because remember, you have to shift them the same amount. All right. So now something they want you to notice is it says draw the line segments connecting the vertices that correspond, and they want you to notice something. So like if I connect A with A prime, B with B prime, and then C with C prime, they want you to notice something about these lines. And the thing they want you to notice is, number 1, they are all what's called parallel, and then they actually all will have the same length. So they are parallel and have the same length. So that's the things they wanted you to notice there, have the same length. So when you translate something, that's always going to be the case if you connected them. Okay, and it makes a cool looking figure too, so that's interesting. All right, so the last thing that we need to talk about, and then you'll be able to work on the worksheet, is this last one right here. And I just wanted you to kind of think through this one. So it says the translation, and so they've given you this rule, maps. And what they mean when they say maps is like after you have translated it, and you know, you took this figure, slid it and then slid it to that one. That's what they're doing, is the actual transformation there. Okay, so this transformation, this rule right here, will make triangle ABC become A prime, B prime, C prime. What translation will map, in other words, take the image, so the figure, back to the original figure? So how, in other words, do I undo what was done? Well, if you kind of look at what this is telling you, so think back to what we talked about all the way up here. What do the rules tell you? So if you notice this one, that's our left and right one, that tells me I had to move it left 1, and that's my up and down part, so that means I had to move it up 2 because it's a positive 2. Then how do you undo that to bring it back to where it started? Well, you do the opposite of this. So the opposite of that would be to go right 1, and then the opposite of this, so we're doing the opposite. The opposite of this would be down 2. So now all we have to do is write a rule that means that. So you always started out with XY. So how do I do right 1? Well, right would be adding, so we'd have to take X plus 1, and then down 2, that's a Y thing, because the Y-axis goes up and down, so it'd be Y minus 2. Okay, so notice, and that's the exact opposite of this, so that should make sense. So to bring it back to where it was, to undo what was done, you would do that. So hopefully this helps. You're going to do the translations worksheet now, and so let me know if you have questions. Have a good day.